Greetings, gentlemen. Alright, so today we are going to do the orthographic projection for this isometric block. So the last time we did our camera, and remember when we're doing orthographic, it is always advisable to choose the angle of projection that you're using and sketch what it will look like first. Like without measurement, just sketch a rough idea of what it will look like before you actually draw it. You will be given the measurements and how it look on the isometric, right? And from this sketch, you will develop your orthographic view. This is what we had the last time, and this is the procedure to get in it. You create your x and y axis, step offset a little bit, and then do your projection lines. So that's what we're doing today. We're going to create this one. But before we start, there are two things that I wanted to highlight from the previous marking. I noticed most person did not know how to get their center lines. If you choose a select center line, right, and here you have your center line looking like a center line. However, it doesn't show when you print it. It doesn't show like a center line because here you have center. Where's that center line here? And we notice it's on line type is center line, right? And center line looks like this: long stroke, short stroke, long stroke, short stroke. So what we do to get it to show like a center line, we select here, right click, select similar. So all of them are selected. Then go to properties. So you can either type in properties or you should see it here on the tab. If it's not here, you just type it in. Properties, PRO properties, and you change line type scale. So this is the line type. You can change the type of line to center line, whatever type of line, but not that because you already selected center line. So now we are changing line type scale, which is here, line type scale, and this specifies how wide the space is or the gaps between the line is. So you change the scale factor to 10 or whatever works for you. So if I change it to 3, you notice it gets small and I can't see anything. So I change it to 10 or whatever scale factor that makes it visible to me. So that's how you get that done. And that's it. If for some reason you have this one looking right but this one is wrong, like for example, this one is, change this to 1. So this one is looking normal and this one is 2, and you want this one to look like that, you don't necessarily have to change it in properties every time. All you do is select the one that you like, type match properties, or MA is shortcut. MA for match properties. Click on that and then you click on the others. Boom. And they become automatically become like the one that you selected. So it's match properties for that function. So you just learned a new function, match properties. So you want your lines to look like an object line, select the line, MA, enter, and select all the lines that you want to change to. Okay. So that match properties, like the properties of that line, it changes other lines to that property. So we're going into the orthographic projection now. So we have done our, analyzed our drawing, given the measurements, and made our sketch. Now the sketch is in third angle projection. It's kind of faint. Third angle projection, which is this plan at the top. So we have the plan here. This is what it would look like. And then we have the front here. And then we have the end elevation here. Right? And the hidden lines represent the gap or the space between the holes in the solid. The hidden lines represent holes or hidden edges. Good. So what we're going to do now is produce this one. So you start with your x and y axis. So we're going to go construction line, x and y axis. Turn on ortho. Right. Then our 45 degree lines. 45 here, 45. Right on. 5 degree right there. Now we're going to step off 10 millimeters. Offset 10. Enter. That side, that side, that side, and that side. So I'm going to change these to projection lines. M, match properties MA. So instead of coming up here to change it to projection lines, I can just match properties from down here. Good. Those are my projection lines. Now I can start drawing. So always start with your front or your plan. So I will start with the front since the front has the most information based on this drawing here. So I know the thickness is 6. The width is 30 plus 30 plus 15 radius, and 15 radius we use diameter 30, so 15 over here, 15 over here. So that's 30 plus 30 plus 30, which is 90. And if the radius is 15, it simply means the radius on this side is 15, the radius on that side is 15. So the width is 30, the length is 90. So I'll go ahead and start with the, well, I can't start so easy. I need to find the height because this is the top right here. So I need to know how much from here down. So I go and analyze again. And the height is from the base to here is 45. To the center point here is 44. So 44 plus from the center up to the top is 20 diameter. So the radius is 10. So it's 44 plus 10, which is 54 is the total height. So I'll offset 54 from here. I can either offset or send this down to offset 54. Enter. Hold on, let me make sure that that's right. Offset 54. Enter. Boom. Alright, so I got the height here. So I offset 6. I don't even have to offset one. I can. So offset 6. Enter. That's the thickness of the base. Now offset from the base. I offset 44. Offset 44. Enter, which gives me the center line. Good. So now I'll draw the base 90 this way. 90. Enter. Up 6 to here. Come across and down. So that's the base. So from the center, I'll go up to the top. That's the center line. And then if this is the top and this is the, so I just draw the circle, the first circle. This is the 44th. This 44 here. From base to this point, which is 44. So I'll just draw a circle here. Boom. That's the radius. Let me check. Radius. Radius is 10, diameter is 20. Good. Radius 10, diameter 20. Good. And then I have some more circles down here, which would be these circles. So this one is 18 radius and 12 radius. So 18 and 12. 18, 12, 12. And they're from the same center, so I'll trim that out. Go back. There. 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 Right there. Good. Then I'll connect the small circle in here, which is, what size is this again? 12, so 6. The radius. 6, enter. And then I'll connect the tangential lines from here all the way up. Notice this is tangent, this says tangent right there. So you wait until it says tangent, connect here. From here to the tangential point here. And then check if the height is right, because something looks, I guess that's how it looks. Height should be 55 in here. 54. Good, it's good. Then this is the, so now they need a center one. The center one is 6 on both sides, 6 in, so 3 on both sides. So 3 over here, 3 over there. So I'll offset 3 on both sides. So offset 3, enter. So 3 there, 3 there. Give me 6. I can drag these, or I can either trim them or drag them. So sometimes I drag to there. Select the endpoint, click on it, and drag there. Select this endpoint, click on it and drag there. Select this endpoint, click on it and drag there. Good. So I can do the center line now. So that is that. So what do I do now? I will basically need to do my cent circles based on these hidden lines. So the circles that pass through here, I need to show them. Looking from the front, I won't see them, but to show that there's a circular hole in it, you need to use hidden lines on these sides to show. And the hidden lines would be from this edge to this edge. So the width of it is radius 15, so the width of it is, no, it's not radius 15, it's radius 2 holes at radius diameter 12, so 6. So notice the arrows usually point to the curve of the radius. So the arrow points to this one, and this arrow points to this one. So it says 2 holes, which is this hole and this hole, at diameter 12, so the radius is 6. So I'll go back here. So radius and diameter is the same thing on when you're looking at a circle and from sideways as length and width, because you have the diameter, or the diameter is basically the internal length of the length from one end to the next end of the circle. So length and diameter are basically the same thing, but when they say diameter, they refer to circle, or radius, they refer to curves or circles, right? So now we need to find where this is, but it is on the drawing. We can see that the center point for this circle is 30 from this center here and 30 from that center. So we'll locate this center first, right? And then step off 30. 30, enter. Alright, so we can delete these now. Alright, not delete, just move it across to the next one. 30, enter. Alright, and then delete it. There are several ways to do it. You don't have to do it exactly how I do it, as long as you achieve the same outcome and everything is accurate and in check. You don't necessarily. AutoCAD is a multifaceted software which allows you to do the things anyhow you decide. You are basically the designer here, so you choose however you want to get it done. As long as you follow the correct measurement and it's accurate at the end of the day, I can tell you how to go about achieving this outcome, right? So you decide that for yourself. Alright, so now that we have these here, we turn these into hidden lines. Hidden, boom. And the scales are small, so we won't see that when it's printed. So we select them and go to properties. You can either click it or type it. Change the line type scale to 10. Enter. No, 10 is too big, so you still won't see anything. So you use something smaller like 6. Alright, 6 looks alright. 6 is acceptable, so we use that. So this looks like it's completed, right? Based on what we have here, center, 2 circles, curve. So the front elevation is done. So what we do now is project our lines upwards. Go back to projection lines. Right there. Project our lines upwards from each point. You can either draw a line every time, or as I say, AutoCAD is multifaceted, so you can copy from point to point. So copy from this point, place that point. Copy from that point, place that point. Copy from that point, place at that point. That point, that point. And I can choose these, but I don't want to do too many at a time because it gets confusing. So I'm doing the major ones first, and then afterwards I come back and do the other auxiliary ones. So this basically gives me all my width measurement from these points, and I'm going to draw them now. So the width, from looking from top, you need to have the width by the length. So it's 30 by 90, and that would be where we start. Start with a box. 30 by 90, and then from the box we just find the center points and draw the curve, right? So we'll start with a box. Like, remember, like with the isometric drawing, right? I always tell you that you start in a box first and then get the curve out of it. So you have to work with, like when you're doing any drawing, you usually work with the center points or the maximum length by maximum width. Anyway, anyway comfortable for you, but for me it is maximum length by maximum width, and then break it down into this. So simple shape first, then break it down into more complex shapes, right? So maximum length is 90 by 30. So we'll go up 30, offset 30, offset 30, enter from here upwards, and then we start farm down curve now. So the center of here, we need to find the center lines. So boom, boom, boom. So change this to center line, boom, and then copy this from here. We just allocate the center of this point so we can draw the circle. Right. These center lines is what will give me the circles coming from here. So we find the center of the 30, which is 15. Boom. Center point, draw it a line. So this is my center as well. And then from this center now we can draw the curve, the circle that cuts both of them. Boom. If we measure it, you'll see the radius is 15. 15, so that good. Then the same thing, we'll just copy this circle. You can draw the next circle or just copy it. Copy the circle from the center to the center here, and then trim it out. Delete. Right, so I have the basic shape of the thing now. So what I'm going to do now is form these holes and the others, right? So the hole is, I don't remember, but we don't have to remember because we have the center line and we have the end points. So I'm just draw. So center point to end point. Boom. Same thing over here. So center point to end point. So that's why I use the projection lines. Because I don't really remember what the width was, but we now have to remember it anyways because we have it already. So the projection from the width of the circle down here so to the width of the circle up here. So the plan gives the information and tells you I want a circle. But when you come down to the front, you see the width of the circle. So if you just get the front alone and see the hidden lines, you wouldn't know if I want a square or a circle down here. So, but that's why you have two views minimum at all times. So you can interpret the drawing accurately. So we're going to move on now and draw this top piece here. So we know that top piece step in is 17, so it's out of 30, so it's step in 13 from the front, right? So we go form the top piece and looking down at a circular feature, you go see rectangle. Just like the sketch that we have here. So this is what you're supposed to have. Something looking like this. So we will step off from here, 17, so offset 17, or you can offset 13 from the front, whichever one you want to do. And then the width from here to here, let's draw. So we go to construction line, rectangle representing the width from here to here. Boom. And then hidden lines now from here to here. From here to here. I'll go on. I say, look ugly, man. It look weird, your fat. Let me try it now. No, sir. It look weird. It's okay. Whatever. These are hidden lines, so we change these to hidden lines. Okay, match properties are just change it like this. Alright, so boom. I have that, I have that, I have that. So what I'm going to do now is basically when you get confusing, you can just start delete some of the extra lines. I have basically everything. Let me see what I'm missing. Except this front piece here and these two hidden lines. So boom, represent the circle here, so right there, boom, and boom, and then leave out the extra line then. So if more about the line, then we just get them back. But for right now, I get rid of them because I'm humbugging. Just the reason I draw the lines is to show you the principles. So when you understand the principle, you can just use skip the line part, the hippo line, and just draw them. As long as them line up properly and meet the requirement, as I say, you don't have to necessarily go through all the steps that I go through. So construction line, and then match properties, we make these in line. MA, enter. Make these in line, boom, boom. Alright. So for these two now, project your line them up. Projection lines. Right. And then I'm gonna use projection line just so bring this up. Stretch them back into place. Right there. Very good. That is that. What else we need? We have all the side ones, the web. So these now, we call these here are called supports because them hold up that round part here, that brace bracket, that this shaft here. These are what supports it. So we refer to these as webs, right? Anything we support are called webs or spokes. Rib, web, or spokes. So these ones are the thin support members that support a piece of a part. So anytime you see them triangular support looking, them not really serve no functional purpose, they just are used for support. So when I left out this, I find some more drawing them in now. So they are actually 6 in width. So I offset 6. Enter from here. Boom. And then we can trim it out, or we can bring it into place right there and right there. And stop on somewhere off here, so up on the edge, so we can trim it up. No, because we don't know exactly where it stops. We don't know, we just project this out and see where it stops. Can I stop right there, so we project it up. So basically, from this point to that point. Right, and it stops there. Let me make it pass a little bit. You know what, I'm not making pass, I'm not enough foolishness. Stop it exactly upon it. Alright, so those are the side part. So that basically I've done for the plan, right? So now we're on the end. But remember what we did last time, you just project your lines across from here and across from here and down, and then you automatically get the end. So boom, go up on projection lines. So boom, go across, go across. So the next time you do this, you do it by your own. Know yourself, you know you can do it. Practice, you know. This is not something we develop overnight, but if you keep at it, you do it no time when you find out. Surprise yourself how well you draw. Alright, so we have the maximum width and we have the height now because we have this and this. So we go start farm it out. Boom. Right here, 30. So this one represents a circle, so you follow the line, come down. We use hidden lines now, draw these in. Boom. Draw them here in. Boom. So alright, those are in. So now we need to work on the height going up. So the next thing we'll work on delete back them here. And we have them already, so no need to throw the drawing and get confused now. So we go project again from these parts now. So boom. I'm gonna delete 45, what that thing? Control Z, undo. So Control Z for undo, yeah? So if I do something wrong, you wanna go back, Control Z. Or this back button here. So boom. Back that already. From here, so boom bang. And then here, so go down. So we have where that stops right there. So we want the height now from here. Coming over. Boom. Alright, so we draw next box. So this represents the height of that. Then this one will represent the broken line underneath here. Because this now go show when you look on it from this direction looking to that direction, you're not gonna see this. But it goes for a hidden line because it shows that you have a thickness. So you have to show it as hidden line. So we go just stretch it, go back to here, so boom, change it to hidden line. MA, match properties. Don't forget that. Change this to and that too. Yeah. We are going with things, you know, bossy. Now you want to work on your piece right here. So going back, boom, work on the height. So we work on a rectangle. This is a rectangle. So project the lines them across now. I notice when I use projection line again, because you can't because you time consuming to be switching your lines. So you know, as long as you know what you're doing, you just do the thing, man. Yeah. So bang, boom, right. So see me, and then You have the boxes, so you can delete this now. You can probably delete them too. So now you have the top part, right? So what you want to know, you want to connect, trim up this. So we'll take with time now. Delete the extra line that we don't need. Make sure you can follow, you know. If you need to trace back your line, then you draw them back. No problem, none of that. No shame, none of that. You understand? Yeah. So you trim up everything, you have it to the maximum height. So you don't know you project your next line them from the internal part to get a hidden detail. That. So these, just stretch them now. Put them in place. Make sure you have the object snap on, because when the object snap here so on, it make your select your points them better, you know. Make everything line up and everything in sync and, you know, good order. Yes, I. So you go again, match properties, MA, work in a hidden line them. Hidden line is for edges that you would not be able to see, so you wouldn't be able to see the edge inside. We show it for sure, say the thickness of this is 6 mm or whatever the thickness it is, you understand? So hidden lines are for sure details that are not seen when you're looking on the side, but it's hidden inside or somewhere. Yeah, so we have that now. So let me see how it look here. So also we have those, so we need the side piece now and this front piece. Support or the web. So next thing we do is connect here, so to here, so bang. And then the side web them now, which is 6, so I offset 6. 6, enter. Bang. And then this no reach it up really. So we project my line from this point where it connect, come here, so we know exactly where to stop it. See that? That's why your projection, that's why we do. We call it orthographic projection, because it's a functional way of lining up a drawing and draw them and then communicate. So when I put measurement and information on this part, we can match it back with information on this part and this part. You can't just have a drawing all over the place, you understand? There's a structured and standard order for your drawing, and this is how we do it, orthographic projection. So when you're in a fifth form and do SBA, this is how we're going to expect you to complete your SBA, in this manner. So we can understand where you draw, say, and read your drawing. It can make a lot of sense. Now this would be hiding behind this, so we can trim that. Now sometimes it may hard to trim like objects like that, solid like that, so you can explode it. Explode. Boom. So that, so you can trim it. TR and trim here, so you can angle to that. Alright, boom. Look like a weed that, yes? Yeah man, look like a weed that. A weed that, man. Yes man. You can delete the extra lines now. Boom. Boom. Right. This one, and can trim this too. See? Now, that's the difference between orthographic and isometric. You see, isometric don't show you the true measurement and the true shape and true feel or size of the object. So you use this for show a client, say, hey, this is what we are trying to build for you. And them say, oh, it look pretty and like it. But this, when you're ready to go to a factory, go make it, send it, go manufacture or produce, this is the drawing that you send. And you usually add what we call dimensions, which are measurements. We tell them, so here's at 34. But we're not reach a point yet. After we master orthographic projection, we go start dealing with dimensions, yes? Alright. So you go do what we usually do now and label your drawing. So instead of labeling it again like mad people, we just copy what we do last time, you see me? And make life easy. Because we believe in life easy, and that's why we use computer drawing. Life easy. Yeah. And you know, so you have to partially mad for blouse and skirt to them as now I do right now. Because I pretend to me I talk to somebody, but I really myself I talk to even check levels. Because I don't watch it yet, and I watch it till about 2 day or 3 day later. So basically I talk to myself till you can't hear me. But not pay me no mind still, it's all good. So front elevation, I'm going to do my end elevation now. Copy, boom, and then bang it out right so. So this is end elevation. All caps all the time. End elevation. Boom. I'm look on the sketch again to make sure it's everything in check. Oh, I'm gonna have the hidden line so for the thickness of this. So I'm gonna go project this up. So you don't make sure you don't left off nothing, okay? When you left off something, that go cause bangarang and Jamaica no want a bangarang. Alright. Boom bang bang bang. Alright. So now this is a hidden line for these points. More when I get the concept of projection, this is why we call it projection. You project line from one point to the next point to get them accurate and line up perfect. Yeah. Some people don't do no projection line, they just use measurement. To you what you want to do. You find a bad way to get around it, do your thing, daddy. And no problem with that. Alright, so eat that now. Look like I will get that now. Look on it again. Analyze, make sure say everything in check. Make sure say match a sketch. You know? Probably call the bridge and say, yo, let me see yours. Make sure say few no match up together. If they don't match up, you don't know. Yeah. Yeah. Look like it's there, man. So I that. So what I can do now is just bouncing. Copy this out of this. Delete them a line now because them not necessary again enough. As long as everything line up, you don't really need them again. And this one kinda big and also scale it down a bit. SC, enter. I'm showing our vibes. It's like how these are different lines. We can make it everything become one by doing a thing we call block. Right? So you select everything, type BLOCK, block, enter, type a name feed, so we'll call it ISO block, ISO shape or ISO object. Then okay. Then everything become one. So when I select it, you see everything just select as one. You do me? Yeah. So we can scale it now. SC, enter, R for reference. Because when I scale it with SC alone, it does get bigger and audio, so you can't do finals. So you type R click reference here, enter, and click any 2 point, and you can control the scaling better. So that, bang bang. You learn by doing here. So me telling you this and that every day now go make no sense. You just have to show it, you see me? Learn by doing. Yes, I. So we go put them in the thing I know and make everything umply scumply. Boom bang. Bang bang. Alright, projection symbol I go there so. That go there so. So we can move this now. And bang it out there so. You understand? And then put the pictures, because usually it's when you put them things up on your drawing, it make your drawing more, say, professional. You understand? You can't just do it normal and just left it so. No, sir. You have to put your sketch them on it and everything. Make me understand, say, boy, yeah, you know, different class I'm on this, I don't know. Umply scumply, rare, te. You know, come up in a row, so. You have to know where you doing your thing. At the road. Yeah? Tell them, man. Do your thing like a pro, you know, man. Angle it like a pro. You do me? So here we go now. Can I label them too? Alright, watch me now. Let me get some words from some. Copy a word from some. Let me do last week. Let me do last week. So this is isometric camera. So copy orthographic projection of the camera. We'll call it block or what you call it? Bracket. We'll just call it a bracket. Bracket. Yeah. Bracket. That's be right. Think so. So orthographic projection of bracket. Just call it block, yeah, man. Yeah. So orthographic projection of isometric block. Orthographic projection of block. Put my orthographic symbol in there. Third angle projection we use again, like last week. Just copy. Can't leave out the projection symbol. Absolutely important for the projection symbol. So bookmark projection symbol. Then we go so. But we can't put this up. It does look weird. How we put this up? Just move this over then. Make it have a, you know, a big vibes. Move it over like a bit. Because your space a drawing for your page, you know, says a lot, you know. It's like you give it a little bit of presentation. You understand? You can't just hitch up. Like some man plant thing and some little thing hitch up right on the whole empty page. No, sir. Scale it up, man. Make it full of the page, man. Or put something. You understand? Make a thing have a little vibe, man. Yes, man. I notice this is an object line. Someone change them now to from construction line to object line. So I go boom. No, select one first. Boom. Object line. That way I get my thickness on it when I print it. You see me? a construction line and a thickness. So we go so boom, and then we go so match properties, MA, enter, and then boom, boom, boom. Yeah, you did me. Yeah, yeah. See that? Nah, pro, nobody can talk to you, Nah, best in the world, man. I tell you that. Nobody can't give you no chat again. Nobody at all can't give you no chat. Che. Alright. So here we know. Give you a drama. So that drama, I give you, you have to hold that close to your heart. See, every circle have you have center line, especially when you do orthographic projection. Every circle have center line, every circle have feature of center line. When you show a circle like this, with like in a circle you have a cross one night, like here. You have a cross one night. Doesn't mean like a cross here, like if you sniper when you play PUBG, so like a sniper point, cross here. You have that now on a circle like this. But whenever you show a circle, sideways you have a single line alone. So let me demonstrate now. So we go center line, bang bang. Then from the center, I have one I go so, turn on auto. One I go so. And remember now, every drawing you do from now on, everything you learn, you apply the same principles them we learn. I'm gonna teach you one thing more than one time, Yeah, I'm gonna teach you one time. You learn it in your head and make it become a part of you. That's how we do things. Grandfather always say, what you learn you shall remember. So you learn it in your head, MA, and never forget it. Boom. You see that? Center line up and going in. Yeah, Alright. So we can copy this from this point now. Copy and put the next center. Cha. Center, bang, center. Hold on, ja. What go on? Move it. Alright, copy now. Copy. Bang it out another center here too. Bang. Put another center here too. Bang. You understand? When the circle them come so, you bang it out just like that. Can't find the center point enough. Hold on. See there? Bang it out. You understand? Yes, I. And then for them I want to know, you just have a straight line alone. So bang. We don't want that one because it's not a round circle. As you mean, you just have this alone night. So you just bang it out just like that. Bang. Now here so said we bang. What? And then for this one you have a center circle just like that. But the center line upon this so you even show it because upon the base circle center there. You see center you have the two circle them. So one up as a now. So you project this one across. Bang. Bang. You do me? Yes I. And then bang it out just like that. Bang. MA. Enter. Boom. Center line, center line, center line. You're drawing not complete without them. Circle again. You want one more. So you project a center line again from point. Oh, that's so. Yes, I. Right, that's so. You understand? And then match properties again. Enter. Bang it out. Yes, I. And that's it, That I it, man. So I said, so now I'm plot this and print it and not normal. You understand? If your work not look like it's not complete, This is what your work look like. Creme de la creme. Alright, email now. I'll plot it fast and then cut the chatting car. Bedtime, So go so. Draw into PDF. Make sure when I plot it properly in a monochrome CTB. Can change the quality to custom so you get 300 DPI. So it's bad and presentable. Make sure you center the plot. Make sure you fit the paper. Then two things here. Please make sure you do that. Because some man give me some lean bar upon paper and some bar when I fit on paper properly. So go up now to A3 paper. Or whatever size we use. Because A3 alone we go ever use. Sometimes we go use different size. But as I improve, I get bigger paper for use. So window. We draw the window over we thing. We preview it and make sure you shot. You see that? We sketched it there. my drawing did there, my isometric did there, my orthographic did there, and everything looked decent. You see that? That we are talking about quality workmanship. Best of the best, creme de la creme, top of the top. You don't know? Yes, man. Everything shot. Good.